So, good morning, students. Welcome back for the Math F242 Operation Research. So, till now we have studied the Model 7. It is probabilistic model having the instantaneous demand for the short period. So, in continuation of that, we have the Model 8. It is also probabilistic model, probabilistic model, instantaneous demand, instantaneous instantaneous demand. Then after we have the short period, short period. But here we are taking that setup cost is not equal to zero. In the model 7, we have the setup cost is equal to zero. Here we are taking that setup cost is not equal to zero. So here also we have to determine the best R. Best R means we have to determine the optimal desired inventory level, which minimize the total expected cost. So what are the function of the expected cost? We have the procurement cost, we have the holding cost, and we have the shortage cost. And you know that for the short period, holding cost and shortage cost simultaneously cannot occur. So here first we define the total cost when k is not equal to 0, that we denote by the TCK, right? TCK. So here we have the procurement cost means setup cost plus purchase cost. Setup cost plus purchase cost if demand is less than inventory level, available inventory level. If demand is less than available inventory level, then there will be the leftover and you have to hold. You have to hold. So here we have the holding cost if demand is greater than the available inventory level. If x greater than equal to r, if demand is greater than equal to available inventory level, then there is the shortage. So C2 is the unit shortage cost and total shortage is the x minus r. So here we have the shortage, and this is the procurement cost having the setup cost plus purchasing cost. So here what if you if you see this much only, so the same thing we have studied in the model 7. It means we can say that ETCK is nothing. It is the K plus ETCR. Means this we have computed in the model 7. Model 7 where K is equal to 0. So ETCK is equal to K plus ETCR. And there we have seen. Now we have to determine the R star. So if you compute del ETC del ETCK ETCKR, right, by the del R, so automatically it will come del etc r by del R. And similarly if you compute the del 2 by del R2, here also it will come the del 2 by del R2. And for this already we know it is the convex in nature. ETCR is convex in nature, and minimum value at the R star. Minimum value at the R star. So here it is written that if you compute the del ETCKR by del R, so it is equal to d ETCR by d C2 in minus C2. And when we same expression FR is equal to C2 minus C naught upon C1 plus C2. C1 plus C2 and D2 by DR2 of ETCKR is equal to D2 upon DR2 of ETCR, and that will come the C1 plus C2 into FR. And in previous class I have told you it is always positive. C1 plus C2 will be always positive, even C1 is negative. Since C1 is the salvage cost which is always less than the C0 and C2 is always greater than the C0, so C1 plus C2 will be always positive. So here we can say that the graph of the ETCK is also convex, right? It also convex function of the R and having the minimum value at the R star. Only the difference is if this is the graph of the ETC, if this is the graph of the ETC, then it is the K unit above. This difference is the K. So this is the graph of the ETCK. It is the graph of the ETCK. Only the difference is, because you have seen here we have the ETCK is nothing, K plus ETCR. So whatever the shape of the ETC, the same shape we have, only we have the difference of the constant K. So here we have the situation. The graph will be exactly same for the ETCK and ETCR, only the difference of the K, constant K. So here we have seen, on this side we have the R and on this side we have the cost, right? Whether the cost when K setup cost is non-zero or setup cost is zero. So here lower graph is corresponding to ETCR and upper graph is corresponding to the ETCKR. So here you can see both are convex with respect to R and ETCK is K units above, than the ETC. Now here if you see at this place we have the R star, means it is minimum, right? Both graph are minimum at the R star. And if you see, if you if you take the horizontal line parallel to the x axis and it cross the y axis at the y naught, y right? So here with the height will be the y naught. So now we have to determine what is the ordering policy. What should be the ordering policy? So let ETCK ETCK R star is equal to y naught. Let ETCK R star, right, it is equal to y naught. This is the y naught. Now, and A be the R where y is equal to y naught meet the graph of the ETCR. So here what we are saying that this point is the A. This point is the A where where ETCA is equal to the ETCK R star and both R is equal to y naught. Both R is equal to y naught. Clear? Now consider the case when initial inventory level I is equal to I2, right? I is equal to I2 where I2 is less than A. So here we have considered this area, right? This area, let the initial inventory can be any number, right, between 0 to A. So here I am saying that I2 is less than A. So when I2 is less than A, so at that time the cost will be, when you are not ordering, the cost is equal to the Y2. Cost is equal to Y2. And here you can observe, from here you can observe that Y2 is greater than the Y naught, means ETC in ETC ETC is greater than the ETC is greater than the ETCK, right? Y2 is greater than Y naught when I2 initial inventory is less than A. And it means if initial inventory is less than A and optimal is the R star, so how much quantity you have to order? You have to order, if no order is placed means K is equal to 0, Q is equal to 0. R will be, because you have initial inventory is I2, so inventory level will become the I2 because you have not order. At that time the total cost will become the Y2. Total cost will become the Y2. If you are ordering, at that time how much you will order? you have to order the R star minus I2, because R star is the optimal inventory level, and initial inventory level is I2. So the difference you have to order, that is the Q star. Q star is equal to R star minus I2. So when we order the Q star item, so the cost will become, when you are order means K is non-zero. When you are ordering, K is non-zero. At that time, etc K R star will become the Y naught. And from the graph, we have seen Y naught is less than Y2. So it is advantageous to place an order of quantity Q star is equal to R star minus I2. Clear this part? Now, second case, if you consider the second case, when initial inventory I1 satisfy the between A to R star. If the if you take the I1, if you take I1 any value between A to R star. Here I am saying that I1 lie between A to R star. A to R star, it means uh, if you are not placing an order, if you are not placing an order, at that time the cost will be the Y1, right? If you are not placing an order, at that time the cost will be the Y1. And when you are placing an order, at that time the cost is equal to the Y naught. If you place an order, then right, the ET star you have to consider, and that is equal to not placing an order. ETC I1, ETC I1 become that time is equal to Y1. Now you can see the Y1 is
Hello, sir, your voice is not clear.
Y is less than Y. So means it implies that uh, what is the advantage, not right,
Sir,
not
voice
place
is
an order.
breaking, sir.
So the same conclusion we have written
So,
here. So in this where second case,
sir, we are not audible.
I'm changing. Just wait. I'm. So what you have seen, second case you have seen. So hello, now are you getting my voice?
Yes, sir.
Yes.
Yes, sir.
So here, in the second case, when I was discussing the second case, so here I have assumed that I1 is the initial quantity, initial inventory level, and it is above than the A, but lesser than the R. So here we are talking for this region, right? We are talking for this region. So in this case, we have considered that I1 is above than the A, I1 is above than the A, but lesser than R. So when we do not place an order, at that time the inventory level will become the R, I1 only. The inventory level will be the I1. So ETCR will be the Y1. ETCR will be the Y1, right? This is your Y1. And when we place an order, so when we place an order, the quantity will become the R star. So so it will be the ETCK R star is equal to Y naught. And from the graph we have seen y1 is less than y naught. So what is the advantage? Not place an order. Advantage is not place an order. So that is written here. So if no order is placed, k is equal to 0, q is equal to 0, in inventory will become the I1 only. Hence the expected total cost will be the y1. Expected total cost will be the y1. If you are placing an order, so when you place an order, the quantity will be the r star minus I1 to bring the inventory at the optimal level. Then the total expected cost will be the y naught. And from the graph we have seen y1 less than y naught. So it is advantageous not to place an order, not to place an order. So now the third case, if you take the case third. So in the case third, we have seen that initial inventory greater than the R star. If the initial inventory greater than the R star, means if the initial inventory is this one, if initial inventory is this one, then if the initial inventory is greater than the desired inventory, so it is obvious not to place an order. If you have enough item, whatever the required one, so naturally it is obvious not to order. So when I is greater than R star, it is obvious that it is advantageous not to place an order because already you have the more item than the desired one. So uh, in the case fourth, if the initial inventory is equal to the A, if initial inventory is equal to A, means if initial inventory is equal to this A, so if you are not placing an order, if you are not placing an order at that time, if you are not placing an order at that time, a cost will be the ETCA, ETCA, and it is equal to Y naught. If you are placing an order, then it will be the ETCK R star, R star, and it is also Y naught. And how much? What is the quantity of order? That is the Q star is equal to R star minus A, R star minus A. That much quantity you have to order, R star minus A, because we have considered the I is equal to A. Initial inventory is equal to A. So here, when you are not placing an order, not placing an order, not placing an order, then the cost is the Y naught. When we are placing an order, when we are placing an order, then also cost is the Y naught. So it is up to you whether you place an order or not place an order. The total cost is equal to total cost are same. So that so here if I is equal to A, then placing an order of R star minus A, that is the Q star units, or not placing an order are equivalent. Means both are giving the y naught is equal to y naught, and give equal total cost, right? Give equal total cost. So from the all cases, case 1, case 2, case 3, case 4, what be the ordering policy? Now you can judge what will be the ordering policy? If I is less than A, if I is less than A, then place an order. Place an order means it is the case first. Place an order of quantity r star minus I. R star minus I. If if I is greater than equal to A, no, do not place an order. Do not place an order. Do not place an order. That is the advantage. So it means, what is this A? This A is unknown now. So here A is nothing. It is known as the ordering point. So the optimum ordering policy is, if initial inventory level I less than A, place an order of quantity R star minus I. If I greater than A, do not place an order. If I is equal to A, you may order, may not place an order, because both will give the same expected cost. The point A is known as the order point. The point A is known as the order point, or the point of indifference. Means point of indifference. Why? Because whether you place an order or not placing an order, both will give you the same cost. So how we can compute the value of the A? So A is what? We know that etc r star is equal to etc A. Both are equal to the y naught. So using this equation, we compute the value of the A. Using the, where etc A is what? Expected cost when you are not placing an order, means I is equal to A, Q is equal to 0, K is equal to 0, right? R is equal to A. Then etc A is equal to what? It is the GA. It is the GA, right? In the model 7, we have represented it by the GA. And etc R star is the expected cost when you are placing an order. So initial inventory is A. So whatever the quantity you are ordering, Q is equal to R star minus A. K is some positive cost, setup cost, not equal to 0, and R will become the R star. So etc K R star will be the K plus C naught into R star minus I plus GR star, where G is nothing, where G is the C1, means so here it will be the G is what? G is the holding cost plus shortage cost. Holding cost plus shortage cost. And here we have the K plus C naught into R star minus A. This factor will come when we are placing an order. When we are placing an order, otherwise we have only the and the shortage cost. So this is the left hand side. etc right hand side, ETCA. It is the ETCA. This is the ETCA, and is equal to, and this is your ETCK, right? ETCK R star. ETCK R star. So procurement cost. This is the procurement cost. This is your holding cost, and this is your shortage cost. When we are not placing an order, we have only the holding cost and the shortage cost. So using this equation, we determine the value of the A, right? Using this equation, we determine the value of the A. So in this case, the optimum ordering policy can be interpreted as SS policy with S is equal to A. Means at this inventory level, we should order, and up to this inventory level, we should order. SS policy is what? If our inventory is less than A, then you have to place an order to make your inventory level up to the R star. Since the initial inventory I is less than A, place an order of quantity S minus I to raise the inventory to the level of S. If I greater than S, do not place an order. That is the optimum ordering policy. So all this illustration we have done. in last class. Is there any doubt to understand that equation? So we have this equation, this question 8.11. The demand of commodity in a single period has uniform distribution. Uniform distribution means x is the continuous. X is continuous with PDF 1 upon 40, x between 0 to 40 and 0 otherwise. The holding cost C1 is rupee 1 and stock out cost C2, this is your C2 is rupees 3. The purchase cost is rupee 1, that is the C naught. That is the C naught. Then what is the optimum ordering policy if initial inventory is 5 unit, that is the I. Assume that there is no setup cost. There is no setup cost. If there is no setup cost, that is the model 7. Model 7. So when we have the model 7, at that time, what the ordering policy we say. So in this case, what is given to you? Fx is equal to 1 upon 40 x from 0 to 40, 0 to 40, and elsewhere it is 0. So what will be the CDF? CDF will be the 0 when x is less than 0, and it is the x minus 0 upon 40 minus 0, that is the x upon 40, x upon 40 when x from 0 to 40, and it is equal to 1 when x greater than equal to 40. So that is our capital Fx, right? So and we know that for the continuous from the model 7, we know that what is the Fr star. Fr star is equal to C2 minus C naught upon C1 plus C2. C1 plus C2, and here we have the C2 as a 3, C naught as a 1 upon C1 is given to you as a 1 and C2 is equal to 3. So it will come 2 upon 4, right? 2 upon 4, that is the 1 by 2. 1 by 2. And what is the Fr star? Fr star from the CDF, we can write it, it will be the R star upon 40. R star upon 40, both are the PDF, CDF. So R star upon 40 is equal to half. This implies that R star is equal to 20. Here the optimum desired inventory level is coming as a 20. Now in the part A, it is given to you what should be the ordering policy. So here if you compute ETC, ETC when I is equal to 5, initial inventory level is equal to 5, right? ETC 5. ETC 5 means we are we are considering the no setup cost. No setup cost. No setup cost, that is the K is equal to 0. So it has only the holding cost plus shortage cost. So what is the expected holding cost? Expected holding cost will be the if initial inventory 5 is greater than the demand 5 minus x into fx and integral 0 to 5 and integral 0 to 5, that will be that will be the into C1 dx, that will be the holding cost C1 into 5 minus x, because what the item you have to hold when the demand is lesser than the available inventory, plus 5 to 40, 5 to 40 x minus 5 into fx into dx when demand is greater than the available item into C2. So C1 is what? 1, 0 to 5, 5 minus x. Fx is what? 1 upon 40. Fx is 1, 0 to 5, 5 minus x, 1 upon 40 into dx, plus C2 is 3, 5 to 40, 5 to 40, and x minus 5, x minus 5, 1 upon 40 into dx, 1 upon 40 into dx. So it will give you, it will give you 1 upon 40, and integration of this is the minus 5 minus x whole square upon 2, 0 to 5, plus 3 upon 40, and here it will be the x minus 5 whole square, x minus 5 whole square by 2, and 5 to 40, 5 to 40. So this will give you 5 minus 5 is the 0, so it is the 0. So this will give you 1 upon 40 and 25 upon 2 plus 3 upon 40, 3 upon 40, and this will give you uh, 35 into 35 by 2. So it will give you total 46. So at that time, ETC 5, when you are not placing an order, it is coming the 46. Clear? When you are placing an order, when you are placing an order, means ETC K, when you are placing an order, you have to place an order so that your inventory level will be the 20. Your inventory level will become the 20, ETCK R star, right? So initial inventory is given to you as a 5. So what the quantity you have to order? You have to order means K plus C naught R star minus I, R star minus I, plus C1, 0 to R star, 0 to R star minus X into Fx plus R star to 40 X minus R star into Fx into dx. That will come, and K is given to you. Setup cost. Okay, this is. So here the cost of placing an order is rupees 20, rupees 10, rupees 10. That is your K. So what will be the optimum ordering policy if the initial inventory is 5 unit? If initial inventory is 5 unit, so it is given to you K is equal to 10. So it is that K is equal to 10. C naught is given to you as a 1. R star is what? 20 minus minus 5, 20 minus 5, 20 minus 5. Initial inventory is given to you as a 5, plus C1 1, 0 to 20, 20 minus x, 1 upon 40 dx, plus 20 to 40 x minus 20, 1 upon 40 into dx, 40 into dx. So that will come ETCK, right? So 10 plus 15, 10 plus 15, that is the 25, plus now integral. So it will give you 1 upon 40, 1 upon 40, and 20 minus 20 minus x whole square by 2, 0 to 20, plus this is the C2. Here we have the C2, C1, C2. C2 is 3, right? C2 is 3. So it is the 3 upon 40, and x minus 20 whole square upon 2, 20 to 40. 20 to 40. So this will give you 25 plus 1 upon 40 into 200 plus 3 upon 40, 3 upon 40 into 200. So it will come 45. So when you are placing an order, then the cost is coming 45. When you are not placing an order, at that time the cost is coming 46. When initial inventory is 5, so what can be the ordering policy? So place an order. So optimal policy is place an order. Place an place an order, because when we are placing an order, then the quantity is cost is 45. When you are not placing an order, then the cost is 46. So place an order. Now in the third part, determine the journal ordering policy. Presently we have the specific ordering policy. Now the general ordering policy, in this case, that is determine the order point A. Now determine the order point A such that if I is less than A, place an order of quantity R star minus I, and if I greater than equal to A, then do not place an order. You take the K is equal to 10. So in this case, you have to determine the order point, right? So in this case, you have to determine the order point. Order point, that is the A. So I have told you order point is what? ETC A is equal to ETC K R star. ETC K R star, because at the point A we have the expected total cost, equal is expected total cost, that is the Y naught. So what is the ETC A? So ETC A will be the, in this we have only the holding cost plus shortage cost. Here we have the procurement cost plus holding cost plus shortage cost. So ETC A will come 0 to A minus X into Fx into Dx into C1. That is the holding cost. Shortage cost will be the C2, uh, C2 A2 A2 40 X minus A Fx into Dx. X minus A Fx into Dx. And what is the uh, is equal to and what is the procurement cost? Setup cost plus purchase cost. Purchase cost means C naught into Q, that is the R star minus A. R star minus A, that much you have to purchase. So R star minus A plus C1 0 to R star minus X into Fx into Dx plus C2 R star to 40 X minus R star Fx into Dx. So that is our equation from where we have to determine the value of the A. So C1 is 1, right? C1 is 1. C1 is 1, and 0 to A, it will be the integration is A minus X whole square by 2 with negative sign, and 0 to A here you take, and here Fx is what? 1 upon 40. So directly I'm skipping that step. Then 3, and Fx is 1 upon 40. So 3 upon 40 integral is X minus A whole square upon 2, and limit is the A to 40. plus is equal to k is equal to 10 and c naught is equal to 1. So r star is given to you 20 minus a, 20 minus a plus what is the value of this one, what is the value of this one, c1 integral 0 to r star minus x fx dx plus c2 r star for r star to 40 x minus r star fx dx. That value you have computed at this place, right? That value you have computed at this place, right? This is the value. So its value, remaining value is that 15, remaining value is 25, total is coming as a, total is coming as a 45. So it means its value is what, its value is the 20 only. So you can say that directly, instead of going in the integration, you can write it as a 20. If you want to integrate, reintegration you can do, otherwise from above you can write directly this value is equal to 20. So from here, from here, what you will get, a and a is, it is equal to 0. So from here you will get the minus 1 upon 40, or 1 upon 40. From here you will get the 1 upon 40 a square by 2. From the first integral you will get this plus 3 upon 80, 3 upon 80, and from here you will get 3 upon 80, and from here you will get the 40 minus a whole square, 40 minus a whole square, and from here you will get 10 and 10 and 20, 30, 30 plus 20, 50, 50 minus a. Here we have the 50 minus a. So on opening you will get a square plus 4800 minus 240a plus 3a square, 3a square is equal to 4000 minus 80a. If you solve this, so you will get this equation. So from here you will get the quadratic equation as a 4a square minus 160a plus 800 is equal to 0. So from here a will come, a will come as 34.14, 34.14 and 5.86. So here we take the a is equal to 5.86 because less than r star. That because if the initial, if the order point cannot be the greater than the desired inventory level, desired inventory level is what, 20. So we take the order point as a less than r. So now from here we can conclude, if I is less than a, I is less than a, place an order, place an order of quantity r star minus I. If I greater than equal to a, do not place an order, do not place, do not place an order, do not place an order. So that is our optimum. So from here only you can see, in the part A, part B, initial inventory is given to you 5. So that's why we have seen it is advantageous to place an order. So that is the journal ordering policy. So this is all the questions from the exercise, from the solved example we have done, and that is the finish of the inventory model, inventory theory. And this will be the course for the forthcoming mid semester examination. So anything, Swin Vijayendra, you want to ask for this question?
No doubt, sir.
Right. So that's all for today. So best of
Thank
luck
you,
for
sir.
the exam.
Thank you.
Sir, there are total seven models in this chapter.
Yes, the model 6 we are not in course.
Okay, sir.
Model 6 is not in course, right?